Hello, welcome back to my channel. Final parts of the semester exam review, Unit 11, Solutions in Acids and Bases. As you can see, it's a lot of concepts. However, I'm going to just focus on the most, heavy concepts that's going to be on the final, and the rest would either not be on the final or it's just going to be a simple question. So I'm going to cover like the pH calculations, the solubility curve, the solubility rules, molarity, so a lot of the math and the solubility stuff. Okay, so the first thing I want to cover is the acid versus bases properties. So like the difference between the two. So what is an acid? How do you know if like a compound is an acid? So an acid has an H in front. And another thing that you need to know about acids is that they donate their hydrogen in a chemical reaction. And then another thing with acids is that the pH value of acids is less than 7. So that's the properties of acids that you need to know. And and one other thing that you need to know is that acids they have a sour taste. So think of lemons. Lemon juice is an acid, hence having the sour taste. And then you have bases. So think of this but opposite. So how do you know if a compound is a base? That's when it has an OH at the end. And when acids donate hydrogen, where did the hydrogens go? It goes to bases. So bases, they accept the hydrogen. And bases have a pH greater than 7. And they have a slippery / bitter taste. So you gotta know the difference between the acid and base, these properties. The next thing I want to cover is acid naming. So again, acid naming all gets to do with hydro versus no hydro. So any acid that comes from the periodic table, they are called binary acids. Then we have oxyacids, so we'll talk about that in a second. So binary acids, they come from the periodic table. Another thing to consider is that they always have hydro in front. And then we also have ic at the, not IA, I meant IC, ic at the end. So for example, I have HF. The name for that is hydrofluoric, because F is fluorine, so that changed to fluoric acid. And then if we do it the other way around, let's say I give you hydrobromic acid, you do your symbols. So H for hydro and then bromic. You know bromic is bromine, and the symbol for that is Br. And whenever you do compounds, like formulas like this, you always do charges at the end. So H, we always know that it has a charge of +1, and then bromine has a charge of -1. So this works out. +1, -1, they cancel out. There's not really much crisscrossing there. Okay? So those are binary acids. Pretty straightforward. Now, oxyacids is where you need to be extra careful. So oxyacids are from the special list, so from the polyatomics. And there is no hydro at the beginning. So no hydro in front, so you just go straight to the name of your polyatomic. Okay? So if your polyatomic ends with 8, your ending is ick. So I ate something icky. And then if you have a polyatomic that ends with "ite," the ending is us. So OUS. And the same for that is Sprite is delicious. So for example, if I give you, let's try that again, HNO3 versus HNO2, just so you can see the difference. So how do I know it's an oxyacid? So oxy means oxygen, so that's how I know this is an oxyacid, because there's obviously an oxygen in there. So NO3 is nitrate. So nitrate turns into nitric acid. Okay? Let me talk about HNO2. So HNO2 is, so NO2 is nitrite, and nitrite turns into nitrous acid. So that's with the naming. Now with the formula, let's say I give you sulfuric acid. We notice that it has an ick at the end, so sulfuric, it's either between sulfate or sulfite. But since it's sulfuric, ick is sulfate. So when we write our formula, we have H, then we have SO4, and then again we have to do our charges at the very end. So H has a +1 charge, and according to the polyatomics, sulfate has a -2 charge, so the 2 goes here. Another example, let's say I give you chlorous acid. So it ends with us, and with chlor, there's chlorite, chlorate, perchlorate, all that. So chlorite, since it's chlorous, it would be chlorite. So H, ClO2. And H has a 1 charge, Cl2 has a -1 charge, so they cancel out. So that is how you do acid naming. It's just a lot of remembering the rules. Alright, next thing I want to cover is the pH calculations. So as for the formulas, I'm not going to rewrite all the formulas. Let me grab my formula sheet. Again, this is what you'll be using, and these are the formulas for the pH calculations. It's all about knowing which one to use. So let me just go straight to the example, and then we'll point out which formula we'll use there. Alright, find the pH with the H concentration of 5.32 times 10 to the negative 7. Okay, so when you read a question like this, you're like, okay, I'm trying to find pH and I have H. Which formula has pH and H in it? It would have to be this one. So I'm going to use pH equals negative log of H. So we just simply plug that in. So pH equals negative log of 5.32 times 10 to the negative 7. And again, I recommend you do the E button here. So as another reminder on how to do that, negative log, and the log button is here. Even if you use my other calculator, same button around this area. We plug in the number 5.32, and the E button is seconds, and then this key above the 7, E, and that's it, and then negative 7. Don't do the times, don't do the 10, just this number, E, negative 7. Okay, equals. My pH is 6.3. And that's it. I'm going to give you another one. Try it by yourself. Alright, find the pH with the H concentration of 6.35 times 10 to the negative 3. So pause the video, try to solve it, and then play once you figure it out to check your work. Alright, you should have gotten pH of 2.2. So even though I didn't ask this earlier, but just as a thought, if it asks like in a question, by solving the pH, would this be, the 6.3, would this be an acid or a base? This would be an acid because it's lower than 7. How about this one, 2.2? It is also an acid because it's also lower than 7. And again, 7 on the dot is neutral, like water. Okay? Alright, let's kind of switch it up a little bit. Let's say I ask you calculate the H concentration with pH equals 7.8. So then again, H and pH, which one? Since I'm trying to find H, which formula is H equals? So going back up here, so the pH and H concentration, these are the two formulas that have both of them, but since I'm trying to find pH equals, that's our formula to use. And for this one, since we're finding H, that's the H equals 10 to the negative pH. So to plug that in, it's just 10 to the negative 7.8. When we do that, we should get 1.58, and remember that E here, times 10 to negative 8. So 1.58 times 10 to the negative 8, lower some concentration. Okay, let's move on to the next portion, which is the solubility rules. And solubility rules is pretty straightforward. I'm just going to give you one example for that. So I'll just go right into the example, because again, soluble means it dissolves. Insoluble obviously does not dissolve. So I'll just write a bunch of compounds. I'll do like the first one, and then you'll do the next two. Alright, NaNO3, CaSO4, and CuPO4 too. Okay, so you always look at the last half of the compound, and you use your solubility chart. And then if you see here, this first half tells you it's soluble, the second half tells you it's insoluble. So if I look at NaNO3, so NO3 is here, it is under soluble, and it has no exception. So it's soluble no matter what. Alright, so try to do these next two. Pause the video and check your work once you get it done. Alright, so for the second one, CaSO4, it should be soluble. So if you see sulfate, SO4, it's under soluble. However, it has exceptions, but does calcium fall under the exceptions? It does not, so it is still soluble. And the next one is the copper phosphate, so the PO4. Here it's under insoluble. It has exceptions, but is copper one of those exceptions? It's not an exception, so this still falls under insoluble. Okay? So those are solubility rules. That's pretty much it. Okay. Next thing is solubility curve. This is where I'm going to pull up my graph here. So you need to know the difference between saturated, unsaturated, supersaturated. In terms of the graph. So unsaturated is under the graph, under the line, excuse me. Saturated is on the line. Supersaturated is over the line. Okay, and you only consider this only when you're given your mass and the temperature. So if I'm giving you a question where it's like, okay, 50 degrees, 40 grams of KNO3, where does it fall on the graph? That's when you literally pinpoint it and then compare it to the line. So let's actually do that as our first example. I'm not going to write a full question, but just the numbers that you need. So 40 grams or 50 degrees of KNO3. So saturated, unsaturated, supersaturated. So let's take a look. So KNO3 is this line over here. And again, you'll have the graph on like the screen, your question, but I also have these graphs if you need like a better view. So what I say, 40 grams and then 50 degrees. It's right here and it's under the line. So it is unsaturated. Okay, So let me give you like 30, 130 grams. Let's do that. 30 degrees Celsius of NaNO3. So NaNO3 is right here. So we look at 30 degrees Celsius and then 130 grams. As you can see here, it's way over. So it is super saturated. Now what happens if I only give you the temperature? Alright, 75 degrees of NH3. This is where you look. If it's only giving you temperature, you just go all the way up to the line. So when is it saturated? So let's take a look here. NH3 is this line here. 75 degrees is roughly here. I go up to the line. So just a rough estimate, it's about maybe 15, 16 grams. So it's saying it takes 16 grams at this temperature for it to be saturated. Alright. Alright, next thing in my list is the molarity dilutions. They give you one of each. And again, you are given these formulas here, molarity dilutions. And remember, molarity is the one that has to be in liters. Dilutions does not have to be in liters as long as the V, both V's are in the same unit. Okay? So, for example, alright, find the volume to make 0.5 molar solution with 5.35 mole. So we have the molar and the mole, so big M and mole. This is the molarity equation. From there, just substitute 0.5 equals 5.35 divided by liters. And from there, you do your algebra, cross multiply and divide. So my liters would be 5.35 divided by 0.5. So I believe that's like 10.7, right? 10.7, yeah, that's right. So 10.7 liters. Let me give you another one. Okay, find the moles to make 350 milliliters of 0.75 molar solution. So again, milliliters, you got to change it to liters, and then solve for moles. So go ahead and try it out by yourself, and then check your work once you're done. Alright, you should have gotten 0.2625 moles. So again, I changed this to liters, so divide by 1,000, I got 0.35. And then when I substitute, basically to find moles, you multiply both sides to get your moles. That's pretty much it. Alright, last thing, very last thing I want to cover is the neutralization reaction. So just always got to know your products for neutralization. So again, what does neutral mean? That is when you have a neutral reaction, basically. So you have your acid, which has a low pH, then you have your base, which is a high pH. Then when you put them together, they cancel each other out, so it becomes neutral. And we know that a neutral solution is water. So we have our acid plus our base. It makes our water and our salt. Okay? For example, there's nothing much to it. Let's say I have HCl. This is the most infamous neutralization reaction. You've seen this multiple times. HCl, strong acid, NaOH, sodium hydroxide, strong base. Put them together, you get water, H2O, and sodium chloride. So basically salty water when you put hydrochloric acid and sodium hydroxide together. So what happens is, yeah, it's a type of double replacement reaction, and we've done this in the past. Okay, so what happens is that, again, the first part of the first reactant goes to the second part of the second reactant, etc. So like the H from the HCl goes with the OH from the NaOH. That makes the HOH, which makes H2O because two hydrogens. And then you have your Na goes with Cl. Okay? My tip is just find the reaction that has water in it. That makes it neutral. So let me just give you one more example. Nope. Alright, try this out. The first product should always be what? Water. And then what's left is what you need to figure out. So we know H, OH, and then what's left? K, and O3. And in this situation, each charge is +1, -1, so it cancels out. But yeah, that is pretty much the neutralization reaction. Just find the one with water in it. That's pretty much what makes it neutral. And then whatever's left is the salt. Okay? Alright, so that is pretty much the end of the Unit 11 review. I hope this helps. Let me know if you have any questions. But yeah, and this concludes the entire spring semester exam review.